Alright, so in this video we're going to continue our discussion on calipers. We're going to do some practical demonstrations with the calipers on these parts. If you check the Pragmatic Metrology website, you'll find this exercise sheet that I have here as well. And you can download this, you can follow along, read it, and measure along with me, or you can do this on your own time. You can find prints for this part and the step shaft on the website as well if you want to make one of these parts for yourself or 3D print it and follow along. If you don't want to do that, you're more than welcome to substitute your own part, trying to find something with the same types of features. So whatever works for you, but check out the Pragmatic Metrology website for this exercise sheet, as well as the check sheet for filling out your measurements, which I have right here. So you can fill out this page, everything you're working with, everything you're writing down. Maybe you have a supervisor or somebody check your work, make sure you're doing it right. So we're going to start going through this exercise on the caliper. So hopefully you've watched the other video where I explained how to use calipers, the best techniques, different accuracy issues, and what they are best at, what they are worst at. So we're gonna do a few exercises with this part. I'll focus mostly on the angle block, and we'll do a little bit with the step shaft. So let's see what this is calling for. Okay. So we've got our drawings, our PM-1 step shaft, PM-2 angle block, and I'll read the exercise description on this paper here. So it says, practice using all 4 functions of the caliper and fill out the exercise check sheet. Measure each print dimension using all 4 functions of the caliper. So what that is intending is, if you pick the overall length of 4 inches, try to measure 4 inches using all 4 functions of the caliper. So you can do it with the outside jaws, that's easy. You can do it with a depth bar and a surface plate. So you may need surface plate, a couple 1, 2, 3 blocks. You can do it with the depth jaw, as well as you can try to estimate it with the outside jaws using your eyeballs, or even setting up some blocks in between them. So that is the intention of this exercise, is to try to get you thinking about how the different ways you can use this, maybe get you realizing there's some ways you can use it that you weren't thinking of. Let's keep reading through the exercise. So measure each print dimension using all 4 functions of the caliper. You may use other gauges to help, such as surface plate or 1, 2, 3 blocks, so anything that's flat. You don't have to verify every single thing on this print. There will be some things that we can't even do with a caliper, not with any of these functions. Some of these can really only be done with 1 or 2, and it doesn't make sense to try to use all 4, but there's going to be more than one where we can do more than just the obvious. And one day you're going to find yourself realizing, oh yeah, if I just bring in an extra 1, 2, 3 block or a surface plate, I can get this measurement that I couldn't get before. So let's keep going. Let's read through the instructions. So first of all, number 1, check your calipers for good calibration. Inspect cleanliness. Practice checking calibration of mechanical tools. Practice setting 0 on digital tools. So I've got a few calipers up here. I got my dial and I got my digital. So first of all, I'm going to switch over to the second camera. All right. So I've got zeros when I close my caliper, and let's try 0 on the outside jaw. Let's check the inside jaw. It's supposed to be about 1 inch on the inside jaw. And let's see, yeah, 997, 998. it may be that the inside jaw is just a little bit off. This is what we saw in the last video as well with this caliper. It's not unusual for the inside to be a little bit different than the outside, something to keep note of, something you may want to fix depending on your tolerance. But for this exercise, where we're just going to have you practice using the gauges, I'm going to keep using this caliper because the digital display is going to be much easier to see up on the TV screen there. So we'll check the depth bar. So we'll check 0 on the back here. So we'll set that up hopefully where the main camera can see it. And I'm going to just drop this down, apply a little pressure, and then take a look at our reading. Ooh, 1,000. So I'm going to do that while I can see it. And there we go. It's a little easier to do when I can look at what I'm doing. So 0 on flush surface between these two surfaces here. And we're going to do the bottom as well. So we're going to drop this down, straight down onto the surface plate, and then we're going to rock this back and forth, try and get this nice and flat and parallel. Let's see what it says. All right, it's reading 0, so we'll do that one backwards. I checked all this earlier before the video, and what I saw here is what I saw a few minutes ago before we started. So the inside jaws are a little, just a little bit off. It's also a good thing to check in the middle of your stroke, as I said in the other video. So I'm going to grab a 2-inch, and we're going to repeat everything we just did with a 2-inch. So I'm going to go on the outside jaws, go a little bit, there we go, 2 inches. So looking pretty good. Looking pretty good on the outside. Oh, now for the depth jaw, turn this around. We can set this up again and bring it down. And as you see, it's registering there on the 2-inch jaw, and it's registering on the surface plate. And there we go. 2 inches, looks pretty good. We'll do the same thing for the depth bar. Hope you can see this on the front camera. There we go, with my hand. I'm holding it steady. 2 inches there. So what that looks like on the surface plate is I've got this bottom side here on the surface plate, and I'm just bringing on the depth bar to the bottom until it reads 2 inches. Let me do that again. Or 1.999. Again, very close. Pretty much what I saw before we started. We could do the inside jaw on a larger ring, like this one here, but I'm going to skip that for now. We're just going to move on, save some time. So that pretty much takes care of the digital. If you want to check it on a dial, you're going to clean off of the faces like I demonstrated in the other video. And you're just going to close up that dial, and you're going to check that it reads 0. In the off chance it doesn't read 0, you can unscrew this lock, and you can just twist this dial to wherever you need it to be. So I am going to put this back on 0. There we go. Looks pretty good. And then I'm going to check, open and close it, make sure it's okay. And you can do the same checks with the inside jaws, the depth jaw, as well as the depth bar that I just did with the digital. It's going to be the exact same procedure, and it's going to be the same procedure with the vernier as well. So if you're going to do this, if you're going to be using a vernier, you can go through the same steps. Doesn't matter. It's a little bit trickier to read, so we're going to stick with the digital like I mentioned before. So let's switch back to our instructions now that we've checked our caliper. If you had any issues, you may need to get a different caliper for the rest of this exercise, or get yours repaired or calibrated. Hopefully you didn't find anything. So we're going to move on to number 2, part measurement. Here's where the bulk of the exercise is going to be. Inspect every feature on each part using only a caliper. This is pretty much the instructions I read to you before. You may require shop math, so some of these features on the print may require some shop math. So you may need to use get out a calculator, get out some paper, and add these together. We're going to be able to do that pretty easily. There's nothing too critical on this print that we're going to work with today. You may utilize other setup blocks if necessary, but no other measuring devices, like I said. So grab some 1, 2, 3 blocks, maybe a angle block, and a surface plate. Should be ready to go. Now, for steps 3, 4, and 5, for technique practice, while you're doing this, I want you guys to practice registering the jaws at different locations. So when you're grabbing onto a part, I want you to practice grabbing at the root of the jaw, grabbing in the middle of the jaw, grabbing at the tip, and see what that does to your measurement. Practice the different pressure that you use, and using the thumb grip if you have one, or a thumb wheel. Practice, holding it in different styles. Holding it with 2 hands, holding it with 1 hand. That can help you in certain situations. And if you have multiple calipers, go ahead and get comfortable using them if you're going to need to. So let's just jump into it now. We're going to start with the angle block. So let me get some things out of the way. All right. So once again, hard to see that on the TV monitor. If you want to go download this print on the website, go right ahead. I'll call out everything that we're going to measure, and we're going to start off with this 1-inch overall thickness. So we're going to use the 4 different measurement methods to get 1-inch overall thickness. So here we go. We've got, I'm going to start with the outside jaws. That's what makes the most sense. And there we go. We got 1.000. We're going to check a few places because in manufacturing, if you only check one spot, that one spot might be in, but other spots may be out. And as you can see, there's a little bit of variation if this caliper is reading correctly. So it seems to be a little bit smaller on this side of the caliper, on this side of the block, and larger on this side, and that could just be a manufacturing issue, but it's all within tolerance. So how might you go about doing the overall thickness with the other features? So let's say, let's grab, let's set it up like this on its side, and we'll do it with the inside jaws. So if I set up a couple of 1, 2, 3 blocks to register on those surfaces, then I should be able to measure the distance between them. Oops, may have to hold it. And let's see, a little bit tricky. 1.002, got to be careful not to be in one of these holes here. 1.005, 1.004. So let's try the other side. Let's register it this way. Get a nice firm grip on it. 998. It's a little bit closer to what I was getting before. So maybe I had a little bad setup before. And I'm rocking this back and forth, and I'm trying, I hope you can see that I'm trying to let this thing seat naturally where it's most comfortable. And that's not loose. I'd say about 1 inch there. Feels pretty good. Again, feel free to check out the video directly off of this camera as well. It may be a little clearer than what you can see up there. So that's how you can use a couple of 1, 2, 3 blocks to grab an overall distance. You may have a part one day where you can't use the outside jaws for some reason, but if you set up a couple 1, 2, 3 blocks, you can do it with the inside jaws. Now we already kind of showed you how to do it, how to get this overall thickness using the depth jaw. So we're going to put this on the rock. We're going to drop this, the fixed jaw is going to be locked parallel to the surface plate. We're just going to drop it down, and then we're going to push on the moving jaw until it registers, and we're just going to give it a little twist, a little rock, make sure that it's seated correctly, and then I'm going to grab it and say 0.999. So it's really kind of a handy way to get some measurements that maybe the part's really heavy, you can't pick it up, you can't turn it, but if it's already on the plate, you can check it this way. And you can do the same thing with the depth bar. So that is the overall length with the depth bar. Now one of the reasons we're getting some different numbers every time I do this, that's one of the things you should be picking up on as you check this over and over again. What do you think is the best way to measure it? For most people, it's quite obvious to use the outside jaws. But as you do this, you should pick up on what the strengths and weaknesses of this tool are. And there'll be, if we measure something else with the depth bar, you might notice that it's got a bigger variation because it's just a less accurate registration method on the calipers. So let's demonstrate that. What the next thing we're going to check is going to be this 400 depth on the depth of the step here. So how are we going to do that? All four ways. We're going to start off with the obvious way. So we're going to start off using the depth bar, and I'll hold it up to the camera this time. And we're going to bring this down. I'm just using my hand, just letting the part move the jaw. Get a little bit closer. And I'm going to flip this around actually, get better registration. Alright, so it feels like a pretty good registration. And I'm reading 0.401. Now one of the things I want you guys to take a look at, the depth bar has this little notch. I hope you can see it. It has this little cutout here. That's going to help you guys avoid radiuses or steps or chamfers. That's what this notch is for. So if you angle this so that the notch takes your caliper away from whatever radius might be down here in this corner, whatever machining method might have left something, that'll get you a nice accurate reading. Oops, probably didn't have that very well registered. So it's a little bit difficult to show you, but this is how I would do it if I wasn't trying to demonstrate. I would set it down flat. I would rock it back and forth until I feel like it's nice and flat, and I'm back to the 401 I got earlier. Good technique. Now you can do the same thing with the depth jaw. So we'll drop the biggest part down, and it's going to have a little bit trouble registering, but I think I can hold it. And we bring that down, and I get 399, so 2,000 different than last time. Still in tolerance if you take a look at the title block. How we might do this with the outside jaws. Well, I measure 1.000 across the outside there, and then I'll measure 0.6, so that makes the shop math pretty easy. And so that pocket depth is 0.4 using just the outside jaws. Probably not the most direct way to do it because it required two measurements and a subtraction versus the single measurement this way. So it's up to you. What do you think is more accurate? Right? The more you do this, the more you're going to have a feel for it. I think the way I did this personally, I get much better registration right now as I'm trying to show you guys when I use the outside jaws than when I try to use the depth bar. But that may not be the case in every situation. The last one up is going to be the inside jaws. So we're going to do kind of like we did before. I am going to try to set up a block and grab, I have to get a little creative, and grab the distance between the block. It's about 398. It feels like it's wiggling and locked in place at about 398, about 399. So we'll just keep going. Make sure as you're doing it, you're recording your measurements on the check sheet so that you can follow up on it later. One of these exercise worksheets, remember to print that out if you want to. So we've done on this print, we've done an overall. We've done a pocket depth. How about we do a hole location? Or how about we'll start off with a hole diameter. We will do, how about this 970 through hole? Okay, so this is called out to be a 970 through wall. So how are we going to do that 4 different ways? I'm going to start off with the obvious way. Obvious way is with the inside jaws. So we will rotate this thing around. And what I'm doing right now is I'm kind of pivoting this up and down, making sure that it's spread out. I'm also rocking the part a little bit back and forth, twisting it in and out. So until it seats perfectly, and I'm applying some pressure with my thumb there. And I get about 0.968, 0.967. So whatever's the biggest number is when it's the furthest apart. So with the pressure I'm using, I'm going to say it's 968. So now it gets a little trickier. How are you going to do that with the outside jaws? A number of machinists, when push comes to shove, they will eyeball it. It's really not recommended, and I personally would never ask you to do that as an inspector, but you know, it's good practice to see. I'm not even looking at the display right now, trying to eyeball it. I'm eyeballing it around 974. Yeah, that might be true. It's even harder to eyeball this one. All right, I'm going to try and register this thing on the bottom. Let me readjust this. So let's try and drop this down. And 972. So the point of this is sometimes you just need a sanity check. You know, sometimes you're like, you're asking yourself, yeah, maybe I made an offset error. You know, you need a quick way to check it. Maybe you grabbed the wrong size cutter. You want a quick way to check it. So it may not be this part. It's quite obvious. Use the inside jaws, but you can do a decent job ballparking it with the other functions. Don't recommend it, but want you to practice, see what you can do, see what you can't do. I'm not even going to bother trying to use these. That would just be a nightmare to try and figure out. So how about next up we'll do that same hole. We'll try to locate the distance here. So there's a 1.005 from the bottom. So we'll do that with the obvious way. I said that was 0.968. Right? That's the diameter, 0.968. Okay. And we're going to come off of the bottom. And using the most obvious way, again, I'm twisting the part back and forth, and I'm kind of rotating the caliper, and I'm letting them seat naturally, applying some good pressure, firm hold, and I'm getting about 518. So let's do a little shop math, and we're going to figure out what that means. So I have diameter 0.968, and I'm going to divide that by 2. So that would be, let's see, 450 plus 30 plus 4. So 484. Hopefully I did that right. And then we got, actually I don't remember what we got. Let's see. About 518 last time, I believe. There we go. We'll call it 518. We're going to add that to 0.484. And we get 2, 10, 1.002. And our print was asking for 1.005. So overall, it measured in print. So we can say, okay, that hole's in the right location relative to the bottom datum. We did that with the outside jaws. If you're not quite sure how I did this shot math, why don't you check out the video on blueprint reading and shot math. I'll go into that in a lot more detail, but if you've already watched that, you'll know pretty much all I did is take this radius of the circle and add it to the distance I got. And you add the distance, you add the radius, you get the center point. And blueprints are always going to be calling holes at their center points. So you have to do a little math because you can't register your jaws on the center point. It's in free space, but you can grab an edge. So you have to measure the diameter, divide it by 2, and then measure from the edge. All right. So let's see. We've done a location. We've done a hole size. What else is on here that we can? Oh, we didn't finish doing it all 4 ways. So how might we do this all 4 ways? Well, again, from the depth bar, maybe we try to eyeball it. Again, it's not recommended. I am not looking at the reading, but 525. Last time I got 518. I think I will give this one a shot. I'm going to try to eyeball, as accurately as I can. Again, I'm not looking at the reading, and I get about 5, about the same thing. I think it slipped out of my hand there. 509 looks pretty good to me. Maybe 510. So another way to quickly ballpark it, and then using the outside jaws. Yeah, you could bring in a block. Try to come off of the block to the edge. That might be a good way to do it. Again, I'm not looking at the number. I'm just looking at the edges of the caliper, and I'm saying about 509. So quick way to do some estimations. Get your brain thinking about how you can use these calipers. The rest of this block, I think you guys can go through on your own. There's a number of steps. There's a number of thicknesses, hole locations. Just practice on maybe 10 of these. Get your 10 different features and get your practice in. I'm going to work with the step shaft now, which is PM01. And we'll do a few of these with these round diameters. So let's just start off with the easy one, the 508. So outside, let's see, 513 is actually out of the tolerance. Print tolerance down here is plus or minus 5 thousandths. And from 508, my maximum would be 512, and I'm getting about 513, 514. So this part was made a little bit out of spec. But if you remember, throughout these measurements, I've demonstrated how to grip it, how to rock it. I haven't really demonstrated what happens when you grab diameters at different parts of the jaws. So let's just see what happens with this one. I'm going to try to grab this one really close to the root, about 516. It's a little bit it's a little bit tapered. Let me move it a little bit. It's about there. It's a little more stable there at about 514. Oops. See, there we go. Now you can see it. And I'm going to move it to the middle. And I get about 512, 511. Then I'm going to move it to the tips. And I get about 510. And that's all just from where it's registered. Because I can actually kind of compress this a little bit more, it gets smaller as I move it away from the root. The closer it is to the root, the less I can deform it just from pressure. Okay, so that's why we measure close to the root, because when you're out here on the tips, this C shape is deforming as you push in. So that's not what we want. We want to be as close as we can to the root, no matter what feature you're doing. Make sure to do your best to get as close as you can. But also remember, calipers have this little channel cut out for clearance purposes. You don't want to be inside of this little channel here, this little cutout. So don't try to measure your part there. That's not going to do it. You're going to need to be on the surface here. All right, so we've done some diameters with the outside jaws. Let's work with this diameter. That's at 749, and with the grab 1, 2, 3 block. If you really had to, hold on. Let's see, how can I do this? How can I set this up? There we go. So I'm going to register and do my depth measurement. It's going to register the jaw on the 1, 2, 3 block, and I'm going to slide it down. We're going to take a reading, 781, and it was 749. So obviously, wasn't able to do it that way. See if I can eyeball it this way. $746, quite a bit closer, and just eyeballing it with the outside jaws. You can try to eyeball it. You could also try to get a good firm grip, but it'd be hard to do it with only 2 blocks. You need a 3rd block to keep them parallel. So I'm just going to try to eyeball it. So that looks pretty good to me. 751. So a few techniques. Again, this is just an exercise to get you comfortable with the caliper, get you comfortable gripping it, holding it, using the different functions. Don't box yourself into just using it for the outside or just using the depth bar. Don't forget about the depth jaw and the inside jaws. So go ahead and practice that, and fill out your worksheets. When you are satisfied with what you've done, I want you to take a look at these review questions and think about how you might answer them. Oops. Let's try this. Think about how you might answer these discussion questions. So let's take a look at them real quick. All right, so question 1, what style of caliper do you prefer? Vernier, digital, dial? What are the advantages and disadvantages? If you had multiple calipers throughout this, go ahead and think about it. If not, if you only use the digital or you only use the dial, you only use the vernier, that's fine too. What is the main difference between calibrating calipers in-house versus sending them out to a certified lab? So this goes into our previous discussion of the fact that when you're checking this in-house, you're calibrating it in-house, you're really just checking that it's in good condition, that it's measuring correctly. Maybe you're adjusting the zero on the dial or the digital, but this is only going to be a check. This is a quick check. This is usually not a good enough calibration um, to satisfy any ISO requirements. Certainly it could be if you have the right equipment and the right procedure, but what I've shown you in the previous video and today, it's just going to verify that your caliper is in good enough condition to work with. But it's not the same as sending it to an outside calibration lab where they're going to do a lot more to it. They're going to check more of the increments that this thing can span. They're going to check that the jaws are aligned correctly, that there's not a lot of wear. So I recommend you send these out once a year, maybe even more often than once a year if you use it a lot. This third, well, what features were challenging for you to measure and why? Just think about, was it the holes? Was it the overall lengths? Was it the locations of things? Was it the diameters? Just try to remember that as you're using a caliper. Now, number 4, on the prints, with your highlighted, with your prints and a highlighter, highlight the requirements you use a caliper for if asked to inspect the part in a real situation where you might have other equipment to choose from. And the key thing here is to consider gauge tolerance and accuracy. So question 4 basically says, grab one of these prints and highlight everything you would do with a caliper. Based on the tolerance, based on the capability. You can even factor in your own comfortableness, level of comfort with the caliper. But just think about it. You have to factor in what the tolerance of each feature is, what the accuracy of your caliper is. So go back and watch that caliper video one more time if you're not sure. Remember, in that caliper video, I basically said anything that's open tolerance, no tight tolerance call-outs. Take a look at your title block to see what your default tolerances are and see if you can use a caliper in that situation. So, okay, question 5. When you measured the same feature on different parts of the jaws, in the tips, at the middle, or at the root, did you see any difference in those measurements? And which location are you going to use in the future? So we just did this a few minutes ago, and we did see a difference when we measured the step shaft diameter. So it is something you should see if you check a few parts on the tips and the roots and at the middle. And then last one, how significant was the amount of pressure you applied? What would be your rule of thumb for future measurements? So that's a good question because whatever pressure you apply, you really need to be consistent. It's the only way a tool like a caliper works. If you are applying a lot of force on something in one situation, I'm really squeezing this down and getting 998, and then in another situation just kind of haphazardly, it's about an inch. It makes a big difference with a tool like this, as well as micrometers, as we're going to go over later. So just remember, your pressure is important. You want to be consistent. Grab some Joe blocks, grab some ring gauges, practice your pressure on things that you already know the size of. And that's it. Once you get through this exercise, hopefully you're going to be very comfortable with your caliper. Just remember, these questions are meant to be stuff that, someone who's using caliper every day should be able to answer these questions very easily. Should be second nature to them. So when you get there, you come back and you look and you'll say, yeah, I know how to answer these without a problem. So I want to thank you for watching this video, and I want you to please visit the practicalmetrology.com website. Look for more videos, look for more resources, such as these worksheets, these practice exercises, and prints, and 3D CADs. And I want to give a quick thank you to the Laney Machine Shop the Machine Technology Program at Laney College in Oakland, providing some of these parts, a lot of these tools, They have a great program there, and you should check it out if you're in the Oakland Bay area. You're interested in a career in machining or inspection, anything in manufacturing. It's a great program. So thank you again, and I will see you in the next video.